All right, let's take a look at Chapter 2, the basics of computing. Now, in this one, we're going to look at what computing actually means. So, this is before the hardware, before any software out there. This is what makes a computer a computer. What sets it apart? So, that computing, what is this anyway? Very simply, these steps over and over and over. We take in information, which is known as input, and you're inputting things probably daily. The text message that you type, the email that you type, the voice transcription that you use, the voice commands, that's all input into some device. It might be a PC, might be a tablet, might be your phone, might be a smart device in your home. All right, all that is input. Now the processing, some could argue this is the computing part, right? Because it takes what we tell it and it does something with it. That's the processing part. This is where your CPU comes in a little bit later. Central processing unit fits right into that, right? This will be the next chapter when we get into the CPU, but this is the brain. This is what's making this happen. Then we want some output, producing a result. Now, this is the part that gets a little tricky with actual computing because, believe it or not, computers probably don't really need this part. Not like humans do. They do have output, don't get me wrong. Like one computer will solve some problems, a solution or whatever, and give it to another computer. And that is input and output. But as far as putting it on a monitor, right, or playing some sound through some speakers, right, that doesn't have to happen with other computers. That's for us as human beings. So we have input, like with a mouse or a keyboard. All right, keyboard, mouse. The processing is what takes place under the hood. This is what we're going to see in the hardware chapter, next chapter, right? And then we have output, which might come through a monitor or your speakers, or you might print it. Right? Do people even print stuff anymore? Right? But the monitor, the screen itself, and of course sound, it could come out through your headset, right? Come out through your speakers or whatever. And that's it. Every app, every game, every website does the same thing over and over and over. That's the loop that we're talking about. Because you input something, it cranks through that 100 miles an hour, right? And then it gives you output, something that we expect. And that's probably 99, 98, 97. I don't have it. I shouldn't put a percentage on there, but that's probably the reason you're using a computer in the first place. It makes your life easier. It does things for you. It does all the processing. You don't have to think as much, right? And I'm not trying to sound like AI. I remember when computers really started getting hot and heavy, right? They started putting them in schools, universities, colleges, and then eventually into people's homes and things like that. It was already in businesses, but people had to learn that kind of stuff over and over and over, right? So they take the input, they get the processing, right? So again, it's not replacing you, so to speak, but it does a lot of work for you. That's the processing part. That's why we use computers. It makes life easier, right? I remember writing out a research paper on hand. Much easier to type that bad boy out and have it printed. Nowadays, you can just talk, right? You can have it transcribed, which is awesome. And then you get your output very, very quickly nowadays. So think of it like this, right? The kitchen. Go into the kitchen. Your ingredients come in, right? That's our input. Something happens at the stove, right? That's the processing. And the finished dish comes out. The dinner comes out. That is our output. So there's the output, the processing, and the ingredients would be the input. And that's the same shape, same idea, just with data instead of food ingredients. We take this piece of information, we put it into the computer, it does something with it, and boo, we get something out of there, right? We get something on the monitor, we get something in our headset, printer, wherever it might be. Now, what makes this computing happen is this over here, the bits and the bytes. Now, I told you at the beginning this was going to be plain English, right? This is not going to be technical. So I'm going to try to keep this as non-technical as I can. So a bit. This is the smallest unit of information that a computer understands. Think of it like a switch. It's either on or off, a 1 or a 0, up or down, right? It's not really anything fancier than that, right? Again, we're out of foundational knowledge. So it's either one or the other. Think of your light switch that you have over there on the wall. right? It's either up or it's down. Right now, of course, it could go in between. We're not going to get into all that right now. That's quantum computing. That's a whole nother discussion. That's not this class. So, with bits, we either have the highs and the lows, the ups and downs, the ons or the off. It's one or the other. Now, what makes this part important is that once we have 8 bits, that gives us 1 byte. Right? And that's what we're talking about down here. We group 8 bits together and we get a byte. So a little bit, a little bit, a little bit, a little bit, and that makes up a byte. And this gives you the combinations to represent a letter, a number, or a small piece of a picture, the data that we actually have. So step back from that just for a second. Think about that, what I just said again. This represents a letter or a number or a piece of something. I said a piece of a picture, piece of data. So quite literally, this letter A right here is a byte. The letter L, the letter I, this letter S, this letter F, all of these, right? Each one of these letters is a byte. And 1 byte, like I said, is 8 bits, 8 little pieces all together. All right, foundational course. 8 bits make up 1 byte. And every byte is a letter, or I should say that the other direction actually. Each letter represents a byte or is represented by a byte, which is, again, 8 bits. Now, the bits, whenever we talk about bits, we talk about binary. Right now, this is not going to be a math lecture. You don't need to know any math. We're not about to get into all that. You don't have to do any anding or know how to combine these binary bits together or anything like that. Just foundational knowledge right now. Just binary is counting using only ones and zeros, up or down. We use that because it's easier to build hardware. Nowadays, this is kind of trivial, the way that we build things. But when computers were very first built, right, they were huge. They took up entire rooms, right? The hard drive, I remember seeing pictures, because this was before my time, of hard drives being taken off of airplanes with a fork truck, with a forklift, right? Hundreds of thousands of pounds of a hard drive. And it could only hold like 20 megabytes or something like that. But it was as big as a car. Nowadays, your smartwatch, that's the size of a quarter, has like 1,000 times more storage capacity on that little thing than the first hard drive. So nowadays, yeah, that's kind of trivial. But when we first started this, we literally had big switches, and they were up or down, right? And we did combinations of those to represent those bytes. And then remember, those bytes represent our digits that we see. Is that a B, a C, a 1, a 2, a whatever? Now, you're not going to need to do any binary math for this course, so we're not really going to talk about it much more after this slide anyway. But you do need to recognize it when you see it. So what you might see out there would be a series of ones and zeros, and you're going to see 8 of them. Okay? So they're always going to be a 1 or a 0, so it could be very easily something like 1, 0, 1, 1, 0, 0, 0, 1. And I'm just making this up, right? This is 8 bits, which is 1 byte. Right? And that is what you would see. This would be a binary number. Now, that may not make a lot of sense to you. Right? And honestly, I know what that means. In hexadecimal, I could convert all that. That's beyond this course. But I can't read ones and zeros. I've never met anybody that can. Right? It's not, I've seen the movie The Matrix many, many, many times. And that's not really binary. It's more hexadecimal coming down through there. But they act like they can read all that because it's the coding behind it. Whatever. It's movies. I get it. I've never met anybody that reads ones and zeros. If you do, that's awesome. I'd love to meet you in person or hit me up on Zoom or something. I'd love to have a conversation. But this is not a separate secret language. So if somebody can read this, that's awesome. I could probably read it a lot slower. But it's the same numbers you already know. It's just written in a way a switch can understand. Remember, a switch, the light switch, it's up or it's down. It's on or it's off. But we might need more combinations than that, just 2. Right? We might need 4 or 8 or 16 or 32 or all the way up to 256 different combinations to represent different characters. And that's why we use binary out there. Now, once we represent these characters, right, and we start taking up space, you're going to start seeing some other terms out there like megabyte, kilobyte, gigabyte, terabyte, right? That's what the KB, MB, GB, TB stand for. And each one is roughly 1,000 times bigger than the last, right? Now, I started at megabyte because most everybody has probably heard that term, right? A megabyte, maybe even gigabyte nowadays, and probably even terabyte. Kilobyte's not one that's used as much, just because it is a lower way of measuring data, right? Or throughput, for that matter, as well. Um, we work in values larger than that nowadays. When I was coming up through the ranks, kilobyte and mega, these two were the big ones. Terabyte was, you didn't even hear about that. And if you had a gigabyte hard drive or a gigabyte worth of space, then you were the rich person, right? You had a server system, you were working for somebody or something like that. So kilobyte is 1,000 bytes. All right, megabyte is 1,000 kilobytes. A gigabyte is 1,000 megabytes, and a terabyte is 1,000 gigabytes. So that's why I said each set is roughly, it's actually a little bit more if you really got to get, split hairs about it. But normally we say it's about 1,000 times larger, right? And that's just the way that we IT folks, we keep that straight in our head all the time. So just to put it in some context for you, a text message that you may get, small email, that might be a few kilobytes, right? Not very large. A song, right? An MP3 wave on your phone or wherever, that might be a couple few megabytes, depending on how long it is and the quality of the song, of course. Now, your phone storage is probably measured in gigabytes still. Depends on when you're watching this video, really, I suppose. If it's too far into the future, it might be terabytes by this point. But a large hard drive, or I have large hard drive, I probably shouldn't have put it that way. Most hard drives that you find in PCs nowadays, laptops and things, they're measured in terabytes. All right, now don't hold me to that. Don't start sending me a bunch of well, I bought a computer yesterday and it only has 400 gigabyte. Okay, uh, I'm not saying they all have to be like that, but for the most part, computers are more days are measured in terabytes. It's just the way that things are going. It's not necessarily Moore's law because we haven't been doing that for quite a while now, doubling as we will go along. But terabytes are still pretty traditional. I know I've got 3 or 4 different hard drives in this PC I'm using for this recording right now, and they're all terabyte level. I don't have anything gigabyte anymore except for my phone. It has 128 gig or 250. I don't remember now. Whatever. So why should you care? Right? Why does all this matter? I'm sitting here rattling things off, right? Well, hey, your phone is out of storage. Well, that has an answer to it now, right? You're out of storage. Well, how much storage space do you have? Well, I think I have a few kilobytes. No, 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 right? You know that's not the right answer. You say, oh, well, I think I have about 128 gigs on this phone, right? And now you understand the difference between a kilobyte, megabyte, a gigabyte, and a terabyte. Because when you're speaking with salespersons, right, you probably want to know the jargon. Don't let them try to talk a fast one over on you. Be like, hey, blah, 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 gigabyte. Wait a minute, I thought this had a terabyte. Oh, you're right, sir. I'm glad you corrected me on that. Right, kind of stuff. Internet plans, usually sold in gigabytes. I said knowing the scale of voice surprise bills. Yeah, that's more of your data camp. Um, when your gigabyte, your speed, usually that's not a surprise bill, but that's where people get upset, right? Let's say you pay for 1,000 gigabytes or a terabit link, right? 1,000 gigabytes, or maybe you just got a gig link at your house, or maybe you got a 10 gig link at your house, or a 2, or whatever the case may be. Most homes don't have 1,000 gigabits, but I'm just throwing out numbers because I want you to have that 1,000 stuck in your head. But anyway, most internet plans are gigabit, right? Now, I'm changing the term because gigabyte, we're talking about storage. All right. When we talk about internet plans, and I made a mistake putting it on this slide, so I'm fixing this as we go, right? This is learning 101. Internet plans, we don't talk about throughput, the data moving, in bytes. We talk about it in bits, right? So this is known as a gigabit, and most of the time we write that with a small b. So that's on me. Um, but they are sold that way. Even though your ISP gets that wrong sometimes, you'll see that on an ad. That's probably why I put that there, because you'll see this ISP saying, "Hey, come get 100 gigabyte, connection speed," and now you know that's actually not true. That's not the right terminology. Maybe you get the files too big to email. I've done this before. You know, the jump from a megabyte to a gigabyte, I get 1,000. But you might be trying to send too much, and you're like, wait a minute, I thought it would support. Oh, I'm trying to send a gigabyte. I forgot. I only have 10 megabytes that it lets me do, right? So you can also size up a new laptop or a new hard drive out there with confidence instead of guessing on what you may need. You go to the store, you get on Amazon, you get on wherever, and you're like, I don't know what I need. I'm so lost. What's the difference between a megabyte, a gigabyte, a terabyte, an exabyte? What is all this, right? Now, hopefully, you have a little bit of that foundational knowledge under there to get that ordered and get the right thing. So this data, all these bits, bytes, megabytes, kilobytes, terabytes, blah, 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 what are we doing with it? Well, that's the processing part, right? This is computing. This is what the computer is doing. It's following instructions one step at a time, and it does this very, very fast, right? This is a little misconception, I think, about computing, right? Because computers are very, very quick, right? Very literally speed of light. All right, it's as fast as electrons can move. That's how fast these switches can go up and down, on and off. Right? So fast computers, if you have a fast computer, right, you compare your computer to your buddy's computer, it just means they can do more steps per second. Not smarter steps. Doesn't make their computer smarter. It just makes it faster. It can do things faster. It can actually switch those switches faster than yours can. And if I can turn my switches on and off faster than you can, I can process data faster than you. I can do more than you can. Right? Think of it like a human. If I can think faster than you, I could perform a task faster than you, or vice versa. Right? Maybe you're smarter than all your peers. Right? So you get a task and you're done 5 minutes before everybody else because you can do it faster. All right? Just means you can process things faster. This part right here where I have they're just very literal fast recipes, these instructions. Computers actually only do one thing at a time. Yeah, one thing at a time. They just do it extremely fast. It makes it look like you're multitasking, right? You're doing a bunch of different things. You've got multiple browser windows open, you're listening to music, you're typing down here, you might be writing some code, you're messing with AI, you got all kind of programs open and you're having a good time. Your computer's actually only doing one thing at a time per core. Let me rephrase that for some of those folks that might know a little bit more. Right, each core, we're going to get into CPUs and the hard drives next chapter, but they have cores in there, and each core is like a brain, and it can only do one thing at a time. Now, it does it within, a half a second, a quarter of a second, a blink of an eye, so to speak, so it can move and do the next thing and do that in a blink of an eye and the next thing in a blink of an eye. So a computer can do 10 things by the time it takes me to explain half of that, right? Because it's extremely fast. So that's what makes it look like it's doing multiple things at once when technically it's really not. Each core is only doing one thing at a time. It's just extremely fast when it does it. So keep in mind, a computer, it's not really thinking. Not even AI is really doing this, right? It's just following instructions extremely quickly and extremely literally. And that is going to matter with troubleshooting later. And I can get on a soapbox about this. And I probably will, honestly. Because, well, we could talk about it just right now for a second. People blame computers a lot. Oh, the computer did this, the computer did that. The computer. No, the computer did exactly what you told it to do. Right now, there may be a mistake in the programming. There may be a mistake somewhere, but a human made that mistake. A computer literally reads ones and zeros up, and that's all it does. We make the mistakes. Yeah, now we talk about computer gremlins, network gremlins, and the computer just acting weird. And listen, I've been in this for a long, long time, and I've said the exact same thing, right? Is sometimes your computer, it just seems weird, right? But it's probably something you did. It's usually something I did. I got out of the program, too many things. Something's happening out there that's making that computer interpret what we told it. All right, so won't get into it too much on that one, but it's usually doing exactly what we tell it to do, even if that's wrong. All right, a computer will do that. So what we're going to talk about in the next chapter, since that was all about the binary and the processing, what's happening, now we need to look at the hardware, and that's what's going to come up in chapter 3. We're going to look at the CPU, some RAM, and some storage, and actually what's inside of the box that's making all this binary, making all this data happen for us and doing all this processing. So I'll see you in chapter 3 here in just a few seconds.